Sharma, Assistant Professor Ajay Kumar Garg Engineering College. Today I am going to start with the next lecture for the subject, that is data communication networks. The topic is for today's lecture is line coding. So, the contents of my lecture are line coding, then we will see properties of line coding and different types of line codings that are available that can be used. So, first, what is line coding? Let me introduce this thing first. What is line coding, why we need line coding and where we have to use line coding. Whenever we want to transfer any information for communication, the original information may be in the form of text, it may be in the form of image, it may be a video. So, all other options are also available. So, this is basically the raw information you want to transmit and this is in the form of analog, but we want to convert this analog information into the digital. Why we want to convert this analog into digital? Because for converting it into digital, it can be stored, it will be more immune to noise, the digital signal is more immune to noise, and for converting this signal from analog to digital, we require an ADC. This is ADC, that is analog to digital converter. Now, what is the operation that is involved in ADC, analog to digital converter? We require 3 different steps, those steps which are present in ADC are: first one is the sampling, second step will be the quantization, and the next step will be the encoding. So, what are these steps? These 3 steps are involved in ADC, in any analog to digital converter. In case of sampling, it will convert your analog signal, that is continuous time, continuous amplitude signal, into discrete in time, continuous in amplitude signal. So, the output of sampler is nothing, it is based on the Nyquist criteria. What is Nyquist criteria? Nyquist criteria is nothing, its value is Fs will be greater than is equals to twice of Fm. This is the criteria that has to be used for sampling. What is Fs? Fs is the sampling frequency, means the sampling frequency, the frequency you want to sample, you have chosen for sampling. What is Fm? Fm is nothing, it is the message signal frequency. You have to multiply it by 2 and the sampling frequency should be equal to 2 Fm or it should be greater than equal to 2 Fm. This is the main Nyquist criteria that you have to consider for sampling. Next step will be the quantization. What is quantization? After you have converted the continuous time, continuous amplitude signal using sampling, you have to just convert the amplitude into discrete amplitude also. So, that process is carried by the quantization, it will be performed by the quantization. It will convert the signal into discrete in time, discrete in amplitude. It will divide the amplitude scale into different levels. Then it has to be converted into encoding. How the encoding will be done? If I am considering this amplitude, let us say this example, this is 0 volt, this is 2 volt, this is 4 volt, then this is 6 volt. Then if I am considering 3 bit of information, 3 bit of data I am considering. So, it will be 000, this will be denoted by 0001, then 8 options are available from 0 to 7. If I am considering V is equals to 3, means 3 bit encoder I am considering. If I am considering 2 bit of encoder, then 4 different options are available, that is 0001, 1011, means from -2 to +2, 4 different options are available for me for the amplitude level. So, this is the work of encoding, number of bits I am going to consider. So, now after listening to this, you all might know about, you want to know about where line coding comes into the picture. After the signal is converted into digital form, like 1 0 means at the before the channel or at the output of the transmitter. The signal is in the digital form, 1 and 0 form. In the same form the signal cannot transmit, means on the channel 101010 bits will not going to travel. It has to be again converted into electrical form. Why we want to convert into electrical form? Because over the wire or for the broadcasting this electrical signal will going to transfer. Now, this will be done by line coding. So, there are different 7 to 8 line codings are available. You can use it on your depending on the application, depending on the distance, depending on the accuracy that you want to transfer, with which you want to transfer the data. So, there are 7 to 8 different types of line coding which we are going to study each in detail one by one. So, here comes the line coding, when you want to convert the digital signal into the electrical form, so that it will travel over a channel. Now, you can see over here, this is the data which is available before the channel, or you can say after the transmitter. This is line coding and it will convert it into the electrical form. Now, this signal will going to travel over a channel. So, this is how the line coding comes into the picture. Now, next is properties of line coding. So, before we discuss different types of line coding, we have to see that what are the properties of line coding. Transmission bandwidth should be as small as possible, because bandwidth is the main criteria whenever we are considering or whenever we are seeing any thing related to the channel. Lesser bandwidth is always required, because as you know that the requirement of internet is increasing day by day, because the number of users are increasing, and from the last 2 years after this pandemic situation, the use of this internet has increased. So, which means number of users has increased. So, the bandwidth is required more. So, whatever for any kind of operation you want to use the bandwidth, it should be used as small as possible. So, that the larger number of users can use a single bandwidth. Second property of line coding is power efficiency. It has to be as small as possible for given bandwidth and probability of error. What is probability of error? This is denoted by PE. Probability of error is associated with digital data. If I am transferring bit 1, because in case of digital or binary data only 2 options are available, either 1 or 0. It may be 1, it may be 0, any other option is not available. So, whenever the bit either it is 1 is transmitted and we have received 0. So, what is the probability of error will be there? So, that has to be calculated. So, the power efficiency should be as small as possible for a particular bandwidth and probability of error. Then error detection and correction capability should be there for the line coding. Example, the bipolar, I am going to discuss what is bipolar. Bipolar is a kind of line coding only. Next is favorable power spectral density is there, which means the DC term should be equal to 0. Adequate timing content is there, that is extract timing from the pulses. Transparency should also be there, prevent the long strings of zeros and 1. What is transparency? In any kind of line coding, we are going to see it one by one. If I am transferring 1 and 0 data, and let us say 5 or not 5, let us take an example like 10 to 15 bits are transmitted as 0, then the connectivity between the transmitter and receiver may break, which will going to arrive in one of the case in line coding. So, what is the drawback of that particular situation? When we are transmitting about 10 to 15 number of zeros continuously, then the receiver may think that the transmission has stopped. It will not going to be transmit any data, means further the data will not be received. So, that is the main problem of using such kind of line coding. So, transparency should be maintained, means after every 0, 2, 3, 0, 1 should come, or the same situation should not be rise. Now, types of line coding. In the broad sense, there are 3 types of line coding available. First one is unipolar, second one is polar, and third one is bipolar. So, basically 3 different types of line coding are available. Unipolar means you have to consider either plus voltage or minus voltage, means above the origin and below the origin, only one case you have to consider throughout your representation. In case of polar you have to consider both the cases, and bipolar also you have to consider both the cases, but the amplitude level will be higher as compared to the polar one. We will see it. The first one is the unipolar signaling. It is also known as on off keying or OOK in the short form. Pulse 0 means absence of pulse, pulse 1 means presence of pulse. Now, I will show you. Let us take an example of 4 bit, that is 1 0 1 1. I want to draw line coding corresponding to this data, that is 1 0 1 1. How I am going to draw it? First, I am going to divide this axis into 4 different equal parts, 4 parts of equal duration. Now, each duration is denoted by TB. What is TB? TB is nothing, it is the bit duration. This is known as bit duration. What is bit duration? Whatever bit we are considering, either it may be 1, it may be 0. So, this bit the whole duration means the time required to transfer one bit is known as bit duration. It may be 2 seconds, it may be 1 second, it may be in microsecond also, but for every bit, for every if you design a system, you have to decide that what will be the bit duration. It may be different, it is not fixed, means universal bit duration is not there. You can design depending on your requirement. So, that is known as bit duration. So, this will be 0, this will be TB, then 2 TB, 3 TB, 4 TB and so on. So, this is the bit duration, let us say it is in terms of seconds. Okay. So, this is the bit duration. Now, I want to draw the unipolar signaling. For bit 1, there will be pulse will be present, for bit 0 no pulse will be present, then for 1 the pulse will be present, again for bit 1 pulse will be present. So, this is how you have to draw the unipolar signaling. What will be the amplitude of this one? Let us say I do not take any numerical value like 5 volt or 3 volt, I am just taking V, which means the amplitude of this pulse will be plus V voltage. So, for duration of 1 bit it will be from 0 to V volt, the duration will be TB. For the second one, for 0 there will be no pulse will be transmitted. So, it will be 0 volt, then V volt and V volt. So, this is how you are going to generate the unipolar signaling. Now, there are 2 types of variations of unipolar signaling are there. First one is not return to 0, second one is return to 0. What is not return to 0? Not return to 0 means it is denoted by NRZ. In case of this not return to 0, this is the half bit duration, this is the half bit duration, this is the half bit duration, this is the half bit duration. It will not going to return back to the origin, which means in case of not return to 0, this is the representation of NRZ, unipolar NRZ. In the short form it is known as UP-NRZ, unipolar NRZ. And if I want to draw the unipolar return to 0 for the same data, then how I am going to draw? This is for 1, this is for 0, this is for 1 and 1. This is TB by 2, this is TB, this is 2 TB, this is 3 TB and this will be 4 TB. Okay. Then for unipolar RZ it will going to return to 0, then for 0 there will be no pulse, for this one this will going to return to 0 and this will going to return to 0 for the half bit duration, which means for the unipolar return to 0 I have chosen only one amplitude, that is plus V, I am not taking minus V. Then it will going to return back to 0 after half bit duration, that is TB by 2. From V to this duration it will going to return back. So, this is TB by 2 For 0 I am not going to transfer any information. This is the main function of this unipolar criteria. Then for next one, this will return back after this half bit duration, and for the another one. So, subsequently this type of signaling will be used for unipolar signaling. This is an example of unipolar NRZ. Duration of the mark pulse is equal to the duration T naught of the symbol slot. So, you can see that for full bit duration the data will be like this one. 0 I am transferring no data, this you can consider. Then for 1 I am transferring the data, 0 for no data, 0 volt will be there, and for 1 this is how the data will going to transfer. Now, the main disadvantage of using the line coding that I was talking about, that if I am transferring 10 or 15 zeros continuously. So, the synchronization between the transmitter and receiver may break, and that condition will occur in this unipolar case only, because for 0 volt for 0 bit I am not transferring any data, this will be 0 volt. So, let us say 15 zeros are there in a row. So, 0 volt will be transmitted for the 15 number of bits. So, this is the main problem of unipolar signaling. This is unipolar RZ. For the half bit duration, the data will reach back to the 0 volt, and 0 volt there will be 0 volt. Then for another, this will be for the half bit duration. So, this is how the unipolar RZ will be drawn. Now, next one will be the polar signaling. In case of polar signaling, I have said that both the positive voltage and negative voltage you have to consider. There are also two options, two types are available for the polar signaling, that is the polar RZ and polar NRZ. A binary one is represented by a pulse, and binary 0 is represented by the opposite pulse, that is G naught T, that is from minus. So, 1 will be represented as plus V and 0 will be represented as minus V. That is the case for NRZ, means for the full bit duration this criteria has to be followed. So, this is how the polar signaling will be done. You can see over here that for 1 plus V will be there, for 0 another minus V will be used, for 1 plus V will be there, for 0 minus V will be there. So, this is how you have to draw this line coding for the polar NRZ. What will be done in the polar RZ case? For the half bit duration, it will going to revert back to the 0 voltage, that is 0 volt. Then in this case also it will going to reach back to the 0 voltage for the after the half bit duration. So, this is how you are going to draw the unipolar return to 0 case. You can see in this waveform also that for 1 this will return back to 0, for 0 it will going to return back 0. So, for 1 it will be plus V for 0 to TB by 2, and it will be 0 volt for TB by 2 to TB. This is how you have to draw for the 1 bit. For the 0 you have to write minus V for 0 to TB by 2, and for 0 volt will be for TB by 2 to TB. So, this is how you have to draw the polar RZ, polar return to 0. Now, next is the bipolar signaling. Bipolar signaling is also known as alternate mark inversion. In the short form it is known as AMI. This is very important, AMI, mostly used alternate mark inversion. It uses 3 voltages, that is plus V, 0 and minus V. So, all the 3 voltages are used in this bipolar signaling. 0 will be represented by absence of pulse, which is same as the case for unipolar. Secondly, alternate voltage levels are there for plus V and minus V. What does it mean? Let me explain with an example. Like there are 4 bits are there. If I want to draw bipolar signaling for this case, this will be TB, this will be 2 TB, 3 TB and 4 TB. For this there will be a full voltage level, that is plus V, this is 0, this is minus V. Okay. So, for 1 bit it will for the first 1 bit it will be plus V, for 0 it will be 0 volt, for next it will be alternatively, means alternate mark inversion. For every alternate one in the stream of bits, you have to change the amplitude. First we have consider plus V, then for the next one you have to consider minus V, for the next one you have to consider plus V, then minus V, and for 0 it will be same throughout the stream, that will be 0 volt. So, this will be minus V, again this will be plus V. So, this is how you have to draw the bipolar signaling. Bipolar signaling means you are considering 3 voltages plus V, minus V and 0, and alternate mark inversion means you are alternatively changing the amplitude of one plus V to minus V. So, this is how you have to draw the bipolar signaling. Now, bipolar signaling is also divided into 2 types. First one is the bipolar NRZ, another one is the bipolar RZ. What is bipolar NRZ? In case of this bipolar NRZ, I have drawn this waveform, that is for plus V. For the first one it will be plus V, for the next one it will be minus V, then for the next V it will be plus, then minus, then plus, minus and plus. So, this is how the bipolar NRZ will be drawn. In case of same, for the case for bipolar RZ, this will be for the half bit duration the amplitude will be plus V, for the another bit duration it will be 0 volt. For 0 volt it will be 0 volt, then again for the next one it will be minus V to 0, then for 0 volt it will be 0, for next V it will be plus V and 0, for the next one it will be minus V and 0, for the next one it will be plus V and 0. So, this is how you have to alternatively you are inverting the amplitude of the bit that is received, that is 1, and 0 will be transmitted for 0th bit. So, this is how the bipolar signaling will be done. So, this is all about the line coding that we have seen. Different types of line coding I have used, that is unipolar, bipolar signaling and polar signaling. In case of unipolar signaling, only single voltage will be considered, either it will be plus V or minus V, and for 0 voltage it will be 0 voltage. The main disadvantage of using this unipolar signaling is that it will going to reduce, or it will going to break the synchronization between the transmitter and receiver. If I am transferring continuously 10 0 bits, then it will going to break the connection between the transmitter and receiver, because receiver will understand that only that transmitter has stopped transferring the bits. So, this is the unipolar signaling. So, 2 types of unipolar signaling are there, NRZ and RZ, that is not return to 0 and return to 0. For the full bit duration, the same amplitude will be maintained, either I am considering plus V or minus V, and for the RZ, that is return to 0, only the for the half bit duration the data will be received, data will be transmitted. For the other bit duration from TB by 2 to TB, the data will be 0 volt. Next, we have seen the polar signaling, which is also of 2 types, that is NRZ and RZ. Thirdly, we have seen third type of line coding, that is bipolar, which consider 3 different amplitude, that is plus V, 0 and minus V. So, this is all about line coding. These are the references that you can follow. and thank you.